know it's going to be a lot on the calculator. So the ones on your homework that I didn't assign you, they ask you just to find the value or the distance traveled. They don't actually tell you how many rectangles to use, because the idea is if you use enough rectangles, maybe if we talk about a limit as the number of rectangles goes to infinity, we can actually get an exact answer as opposed to just an approximation. So to show you that, I want to show you how to use the calculator, and we're going to do 10 rectangles, which still would be a lot to do by hand, but then we'll do 100 rectangles and 500 rectangles. And so the idea is if they ask you to use RAM to find the value, and they don't tell you how many rectangles to use a really big number, and you should be able to approximate the exact value. So maybe we should see if my calculator shows up on this. But the whole idea about a program on your calculator is it's very handy, but you have to know how to use it, how to execute it, because if not, it's going to say error. And when I used to make people type in the like 40 lines of code to make this program, which is really cool if you'd like to see that code, it's in your calculator, and I'll show you that you can edit it, and if you edit one thing, it changes the whole program, and it runs wrong. And so it used to be when I made you do that, it wouldn't work, or it gave you the wrong answer, and then I had to go through your 40 lines of code and find out, oh, you forgot a comma here, or you forgot an equal sign here, and that changes everything, which is why when people say they want to design video games, they don't realize it's not as exciting as playing video games. There's a lot of code and such involved like that. It's kind of a cool idea if you ever want to know. But here's the thing that people forget a lot. I don't have the program on here because I didn't want to write the 40 lines of code on this. But you got to write the equation here that you're trying to find the area or the distance traveled. So I believe this example is 1 over x, right? So we're just going to hit 1 divided by x on our y equals. Do you have to put No, just go to y equals and type 1 over x. If you don't type your equation in here, or if you have another equation in here, the answer that it gives you will be whatever that first equation is. And so that's an easy step to forget, but it's really important. You have to tell the calculator what you're trying to see here. And so 1 over x, that's just a rational function. What we want to do is tell it to find the area between a certain value. So go back to my notes here. And they're always going to tell you between 1 and 3, right? And so why did I put a and b? Because in this program, they use the interval as between a and b. All right, so when we use this program, it's going to ask you, what does a equal, what does b equal? And that's just the left and the right endpoints of where you're enclosing your graph. It's also going to ask you for the number of subintervals, which means the number of rectangles. So on your graphing calculator now, go to Program, and at the top, most of you only have RAM. Some of you, there's some random things that people have put on there. Probably not even real programs, just notes they've written to themselves. But the options are execute, edit, or new. New is if you're writing a new program. Edit is if you're editing an old one. We want to execute this program, which is already highlighted, which means you can just hit enter. And it should say on the front screen now, program ran, right? Hit enter again. So enter times 2. And then it just tells you what to enter in. What is A? A is the left endpoint, which in this case, A is 1. So A equals 1. So just type in 1 and hit enter. And then it asks you what is B, which is the other endpoint, which in this case is 3, and you hit enter. And we're going to start with 10. If we did this for 10 rectangles, number of subintervals comes up next. And so I'm going to type in 10. It will give you the left, right, and midpoint estimates. And so it tells us that the left is 7.88, the midpoint is 8.66. Wait. Nope, not what I got. Oh, look, forgot to change my graph. I was doing x squared. That would be a problem. Sorry. Thanks. Just kidding. 1 over x. Now I got to do it again. Yeah. Program.
How many?
3, right? AP calculus. We do 3 decimals. So we would do 1.166 in for 100, and then we'll see if 500 sometimes takes like definitely like 3 minutes. You'll know if it's working because up in the corner will be a little line, meaning that it's thinking, it's running the program. 500 rectangles is a lot of rectangles. So you just do that, like you don't have to change the function because it's the same thing, so you just hit program again. And the nice thing is, if you know what A and B stand for, you're just plugging stuff in.
Oh, so you're saying it takes a while to figure it out?
Like, yeah, like it's thinking. So that little line up there at the top means it's thinking. Sometimes 500 is like ridiculous because you just sit there and you think it's broken, but it eventually comes up.
Well, I don't know. If I could solve one of these problems in 3 minutes, I would consider it.
100 rectangles in 3 minutes, not that. Oh, my. So,
Not too bad.
notice as we do 100 rectangles that those are getting closer together, right? Like they're getting closer to the same number. That's why it's really nice, right? Like making 4 rectangles is a nice way to do it on pencil paper, but to get an exact answer, or as close as the exact answer as you can, you need to do a lot of rectangles. Is it still thinking? Everyone got there? Yeah. 500. 500, nice. Okay,
I'm just waiting.
On the AP exam, on the no calculator portion, there is usually a question or two involving using rectangles, or in some case we're going to learn about trapezoids, to estimate. Pencil paper, they will never make you do more than 6 of those. Is there ever going to be a question on the calculator part that you could use this program to help you? Probably not, because they know there's a program out there. But, you know, you never know. Like, if it is there, you can use it. So, on the calculator portion, you are required to have a graph calculator. Anybody has theirs working yet?
Oh, yeah.
Okay.
But will the left rim and the right rim always be the same distance away from the organ? Or at least maybe it's not like ours. I don't know. I was just looking on mine where I found it. They're always like.
I think it depends. No, like it depends on what the graph looks like, right? Like it depends on how much it's over and under. If you graphed the one from the homework yesterday, part of it was increasing and part of it was decreasing. So sometimes your rectangle, like it's not going to be symmetric. If your graph is nice and symmetrical, then I think you're right. Like you can notice a pattern of where they are. Oh wait. I don't know how I'm going to go like 4 decimals just so I can see this here. 0.0999. 1.0996, 1.0972. Is that true? Is that what you got? Why did I change that to 9? Zoom, that'd be 0.0986, and this would be 1.0972. If you were saying, let's look at the 2 questions I did not make you do yesterday, unless you just wanted to do for fun. It says, use RAM to estimate the area of the region enclosed between the graph of F and the x-axis from A to B. They don't tell you how many rectangles to use, which means I don't want you saying, well, for 4 rectangles, it's this, right? It means they want you to get close, they want you to get to a point that your LRAM, your MRAM, and your RRAM are pretty much the same number. Does that make sense? And so, like, if this was a question on the homework and it said, what is the value? What is the area, as close as you can get, I would say it's about 1 point, I don't know, 099, or we want to round it up? Like, I don't know. I'm just going to go with this. Because 3 decimal places, it's about that, right? For the most part, you're going to see on these, like you might actually even get like a like you might get to a point that it's like an exact answer, right? Like it might end up being like 4.5 all the way across, so you don't have to worry about, am I estimating right? What I'm looking for on these right now is that it's generally the right answer, right? Like if you would have only done, this one is not, even at 10 rectangles, if you pick the MRAM, you're going to get pretty close to the right answer. But if you would have picked LRAM or RRAM, I would have, at 10 rectangles, I would have marked that wrong because that's not close enough to what it is if you did 500 or 1,000 rectangles. Does that make sense? This, yes, sorry. So 9 and 12 is your homework tonight. We are going to, tomorrow, move on to section 5.2, which is relating this back to calculus. Because really what we've been doing these last couple of days doesn't really feel like calculus. I mean, talking about an infinite number of rectangles, kind of talking about limits and all that. But tomorrow we're going to relate this to something called a Riemann sum and get into integration and the integral and how we can find exact areas instead of using rectangles. We can use calculus to find exact areas instead of estimating. So that's kind of where we're going with this. But you only have to do number 9 and number 12 if you haven't done the rest of the homework. Like there's only been 8 problems assigned so far for this semester. So get caught up.
So, you want us to do it for the numbers, like, uncalculated separate trips? I don't want to bracket.
If you want to just jump, like, I kind of like doing the 10, 100, 500, just so you kind of see the progression of it. But as long as you plug in like 500, you should get the right answer. Does that make sense? So like if you just do 100 or 500 on those, you should be able to see that
So
it's.
really there's no work, because they really need to go all the way up to 500. 100 is gonna be good enough.
Well, you tell me when you do it and see if you think. Like here's how you would know. If you plug 100 and you feel like these are not close enough together that you could, you see what I'm saying?
Yeah.
If you do 100 and they're pretty much all exactly the same, you're like, oh, I'm just going to estimate this. You don't have to go any bigger. You might do that with 50 sometimes.
So really there's not a lot of work.
There's not a lot of work to show. You can just write it down.
I like this stuff.
So that's why there's definitely going to be a calculator and a no calculator part of your test. That's why when it says use 4 rectangles and I say don't use a calculator, that's why you must show work. So like on 5 and 6 from yesterday, you could do those on your calculator, but I'm looking for work on 5 and 6. Does that make sense? Okay. So that's it. It's a really short day today because we just didn't get